Me ma wakwa babiem e de ba Kodan Academy. Abra ye tia learners addition yi hye. Me pese ye dan ye ni na ye hwe bibia ya to din process monitoring. Process monitoring. Ya kasa process monitoring kra process monitoring e ye den. Na kasa process kra process e ye den. So what is a process? You download these softwares and as you download the programs and install it on your computer. So these programs or softwares that we download and install on our computers, when we start running those programs or softwares, they become a process. And this is a process. A process is a program that is currently running. And the emphasis is ma download the notepad. Na sa notepad ya ma download the se notepad no membie sa app no mu se ebia me use sa app no na se computer no so a it is not called a process. So it becomes a process only when I open that program and the program starts running. So a process is a program that is currently running. Another example, you want nano program. So nano is a text editor. This nano program we say minko be a program we mu and I say if the nano program is not running but it is on the computer but it is not running, we are not using that nano programmer, then it is called a program. But when we start using, we go and then we run that nano program. Now it starts running inside the computer. There we can start using that particular programmer. It now changes from being a program and then becomes a process. And a process is a program that is currently running. So nano is a program. It becomes a process when it starts running. The process is a program that is running in the computer's memory. Any program biana best start is running inside the computer's memory. And as any program biana, you the user of the system, when you go and then you start it so that the program can now be used by you, the user of the system, that particular program now becomes a process. So it changes from being a program to a process. The program biana ebe running one, it uses an amount of memory. In the memory where I make a RAM. So the RAM that is inside the computer, when a program starts running and then it becomes a process, it uses its own memory. This program now that is running as a process gets its own ID. This ID no, you refer to this particular ID as a process ID. The PID and the emano. So one, every program that is running in the computer's memory, a babe process, has its own memory usage. It gets its own process ID, PID. And so ebenya the user who is running that particular program. So every program that is running, so permit me to start using the term process. So every process has an owner or belongs to an owner or someone who is running that particular process. So owner, user running the process. And it was state. So the state of the process could either be running, sleeping, or stopped. Until you better dive deeper to look at these various stages of a process. Until the person would say, I say, we have a program. When the program is on the computer, now say you're running that particular program now, or the program is not being run by the system, it is called a program. But when we start running this programmer, now it changes from being a program to become a process. Until in Linux operating system, and as I say about Linux environment as well, we have some groups of commands that we use to check the state of processes, that is programs that are running. So commands that show what programs are currently running on your system, we refer to this group of commands as process monitoring commands. In the case of process monitoring, the eka nyina say programs that are running on the computer, what are the states of these programs? Are they running very well? Are they sleeping, or they have been stopped? So we use some group of commands to check what is actually happening inside the computer. So we use process monitoring commands to check how much CPU and memory each process is using. Every program be running uses an amount of CPU, it uses an amount of memory, and because it has its own memory usage. So we use this group of commands to check how much CPU or how much memory is this particular program or process using. And then some of these commands also allow you to watch these processes live. So when any program is started, you are able to see who started the program, because it will give you the owner of the program, and then the memory usage of the process, and also the CPU usage of the process. So normally we use this command to monitor the performance of the system. Is there any issue going on with the programs or processes that are running? And also, if there is any problem going on with any of the process, we can either kill the process or to stop the process. Every process has a PID. So the PID stands for process ID. So Ebiana, we have the nano program running. The nano program will be assigned a special number, and that special number is used to identify the program that is running. In this case, Rebecca said the process that is running. We use these special numbers to stop the program, or we will say to kill the program. So stopping a program, we say we are killing the program in Linux terms. So to kill or to stop a program, we need the PID of that program in order to be able to stop or to kill that particular program or to kill that particular process. And what are some of these commands? One of the commands that falls under process monitoring, the PS command. The PS command. The PS command. So the PS command, actually the process that are running in our current terminal. So we saw that Linux deals with terminal. So we can open so many terminals on a Linux computer. So when we open a particular terminal, the programs that we use that terminal to run, the PS command shows us all the programs that are being run by the current terminal. So yako Ubuntu server usual, I can type PS command, press enter, and now it will show me the processes that are attached to this particular terminal that I am using. So these are the processes that are attached to this particular terminal I am using. So I have the PID, that's the special number that has been assigned to the program that is running or the process that is running. And then I have the TTY, which stands for the terminal the process is attached to. The terminal the process is attached to. Then we have the time, and then the CMD, also standing for the type of program that is running. The PS command shows a snapshot of processes running in your current terminal session. So snapshot, like I said, a snapshot simply refers to one-time picture of what is running. So it is just like you taking a picture of something. So when we take a picture of something, so we take this out the picture now, the picture doesn't give you live information about that particular place or that particular thing, but it gives you one-time information about what was actually happening. So that is how the PS command also work. A snapshot refers to one-time picture of what is actually happening and not live update. We have the PID, which stands for the process ID. Then we have the TTY, the terminal the process is running in. Then we have the time, CPU time used by the process. Then we have the command or the program name. So PS only shows processes that are linked to your current terminal. So you don't see full system processes. You'll be able to understand the reason why we are saying the PS command only gives one-time picture information about what is happening in your system. It is a terminal usual. When we say the PID, the special number that is assigned to the process that is running, the terminal that is running that particular process, and then the CPU time that the process is using, the name of the process that is running. So meaning they have only 2 processes that are running on this particular terminal. That is the bash process, then the PS process. So the next command that you can assemble the PSOX. The PSOX. This PSOX command, when what it does is that it shows all the process on the system in a detailed format. It is a person you all the processes that are running on the Ubuntu server. We use the PSOX command, So we have a PSOX command. So let me type this command PS. Before PS, let me clear the screen. Let me type PSOX command. When I enter. So me enter, you can see that this has given me all the processes that are running on this particular Ubuntu server. So the PSOX command is like the big brother of the PS command. Here you see some PSOX command to get full details about the processes that are running on the system. To juma enu edi ene say ye share PS command no enkwano. Ye hu say PS command no enkwano eno nko eyi processes that is being run by the current terminal. So ebiana wo be one terminal and we use that terminal. Programs that are being run by that particular terminal no eno pe na PS command no ebeyi amount. But se ebo PSOX no na ewo ox no mu e kire say system no enyi programs and processes are all the users that are on the system are currently running amount. Na ewo ox no mu sa dwuma no na eno no edi process from all the users. You no so no nya more details about the program. What the program is actually doing. What the program or the process is actually doing. And X and so it should include all the terminals that are on the system. So any terminal biana running a particular process should also be included. So PSOX command doesn't limit the output to only a terminal. It picks all the processes that are being run by other terminals on the system and then show these processes to you. The above PSOX command now, this is the result that we see. Some result we endorse, and then you can't read through all these processes that are running. The Abiana Opesa will check if a particular process is actually running. What we can do is say, let me clear my screen. The Abiana me person me who a particular process that is running. You say me person me who say Firefox program no running and I say running. So what I can do is that I can type PSOX. We use pipe, a vertical symbol. So we shall keyboard no so some of the keyboards right on top of the enter key you see the pipe key over there. Until you use a pipe symbol way and the combining commands together. The command way running we are. What the pipe will do is that it will take the output of the first command, that is the command on the left hand side, the output from the command on the left hand side, and pass that output as input to the command on the right hand side. Me person me say Firefox running. There was another command that a friend grep. The grep so you then we dive deeper on how the grep command also work. So for the meantime, you should grep command and search for terms that are in some output. The Abiana, a certain command gives me a particular output. I want to know if there are some key terms in that particular output. I can use the grep command to search for those terms. So in this case, because I'm searching if Firefox is indeed part of the PSOX command, and I say Firefox, running as a process. Then me bought sub PSOX pipe, then I pass grep command, and then I pass Firefox to the grep. So what this command will do is that the kind PSOX, that all the processes that are running on the system, but out of the processes, then output will be passed to the grep command. The grep command also and also any output now I should share for Firefox. Okay, Firefox away, then it will display only Firefox for you on the terminal. So we are using the grep command as a filter to filter for what we need or to search for the processes we need. Timebo enter, don't say a Firefox and amame. So nipa or running this particular program Kodan. The Kodan running this particular program Firefox. Example px ox. Na afe mamen pipe no na to the grep command na me search for Python. Me person me say Python running as a process, and as a Python is not running as a process. If Python is running as a processor, what is the PID of this particular Python? Timebo enter. Bonsa amami okay, Python is running. Timehu Python so the grep command no ebe fetch ebe hwehwe the output no mu baby a Python bia no, it will take only those results and then display it on the terminal for you. Timamen clear screen ebiem na fe member px ox command di na the ebe ne se mamsan so use the pipe symbol ni ebiem to combine commands, but we no the ebe say yebo ps ox command no enko a you say output edema no edoso, so we can't actually read everything. Yentumi read the output ni nyina nti ebia na yepese yehu maybe some few output per ewo terminal no, so na mum enye all the output and also no we can use the ps ox command, then pipe it to a command known as head. The head command it is capable of showing us only the top result, some few top result. Timebo enter, instead of showing all the results on the terminal, the head command is able to give us some few output so that we can be able to read. And the user who is running that process, the PID, the special number assigned to the process. We have the CPU usage, the amount of CPU that is being used by the process. Then we have the memory usage, that's the memory percentage, the amount of memory that is being used by the process. And the virtual set size. The virtual set size determines the amount of memory that can be used by the process. The amount of memory that can be used by the process. Then we have the resident set size. RSS. The RSS the actual memory that is being used by the process. The actual memory that is being used by the process. And the TTY the terminal that is controlling that particular process. And normally you question mark question mark it means that particular process is not attached to any terminal. That particular program or process is being run by the system itself. And start the state of the process. The state of the process. So what kaya you some status of what of process. You can sleep in, you can running, and you can stop. So the start colon the state of the process, and when was the process started, and then the time of the process, and the process name. The process name and the command section and as the command colon So you come back to this particular PPT. We have the PID, the process name. We have the PPID, that's the parent process ID. Some programs run as a result of starting other programs. And to say ABI started program A. Program A may need program B before it can work. So program A will automatically start program B. So in this case, program A becomes the parent of program B. So program B now becomes a child of program A. And the Yabaka's a parent process ID. Then we have the user. So the user is who is running that particular process. The user who is running that particular process. And as a because a UID. Then we have the CPU usage, we have the memory usage, then the virtual memory size, the total memory a process can use, the resident size memory, then we have the TTY, the controlling terminal, and then we have the start, the process state code, whether sleeping, running, stop, and we have another process called zombie. So we look at that zombie. Then we have the start time, then we have the command or the program name. So when do we use PS or PSOX? Yeah, you see PX and as a PSOX to check if a program is running. So your person with a program we are running and I said this particular program is not running. You bet me you see PX and I say PSOX, you know, and they are checking if a program is not running. The can your person check and we say program be running and I say our program no running. And I they taught me you know, we use the PS or PSOX command to debug issues. If a particular service stopped abnormally, you can use the PS or the PSOX to also check that. Then sometimes what hackers do is that they install malicious softwares and as a suspicious programs. And to be able to detect these softwares, you know, you have to use the PS or the PSOX commands to check the processes that are running on the system. What check now, so no, this particular program is quite suspicious. Then you can terminate that particular program. If you also be another person end the program that is running, the process that is running, we want to end that particular process. So to end a process, you know, we need the process ID, the PID. So you have to use the PS or the PSOX command to check the process ID of the particular program or process you want to end it. So check if a program is running, debug issues, find suspicious processes or detect malware or backdoor, and then to find the PID of a process to be able to end the process. The next command that you can the top command. The top command. This top command we know so the is it gives us live preview of what is happening inside the system, the processes that are running, the system activities that are happening on the system. So top command, you know, unlike the PS command, it gives us just a snapshot of what is going on, but it doesn't give us live update of what is going on in the system. No, the top command gives us live continuous updates about the processes of the system. What is actually going on in the system live. We would think of the PS command like using a camera to capture a picture. So the picture will give you only the information that the camera is able to capture. But say you should top command, the top command is like installing a CCTV camera somewhere, which gives you live updates about what is going on in that particular area. It is a top command, you know, so akwa is the CCTV camera, which gives you live updates about what is actually happening on the environment. So if we want to know what is going on in the system lively, we want to see it, the changes, you know, are happening and as a process in start here, then it shows on our terminal so that we are able to see it. Then we use the top command. So top command show a live continuously updating view of system activity and processes. This command gives live stream of what is going on in the system. Update every few seconds. So it updates itself every few seconds to give you live preview of what is going on inside the system. So let me clear my screen and then type the top command. To me, enter. Now look at what will happen. Within few seconds, it gives us live updates of what is happening on the system. So unlike the PS and as a PSOX command, it gives us one-time view of what is going on in the system. No, the top command gives us live preview of what is going on inside our computer system or inside the Ubuntu server. So we have the PID, we have the user who is running the program, then we have the CPU usage, we have the memory usage, then we have the time, then we have the command that is, or the process name. Yeah, so just almost like the ps or the px command, but this one, the difference is that it gives us live preview about what is actually going on. Now my main train wadwin nsi bibi so ewa ha. Also say you see top command now. When you check this particular page that you are looking at, we have top section, then we have the table section. And the top section now. So the top section is just like you running the uptime command. The uptime command. So that top section, it gives us the number of days and the number of minutes or hours the system has been running, the total number of users who have logged in into the system. So in this case, my system has been running for 59 minutes, not even up to an hour. It has been running for 59 minutes because this is my local server. Then the number of users who have logged in into this system is only 1. Then we have the load average. The load average, refers to how busy the CPU is. Then say about the next row now, you tax. So tax, when you check the tax, it gives us the total processes. So I have 97 total processes. So out of these total processes, how many are running? Only 1 is running. So only 1 is actively running. Then we have 96 sleeping. So all the processes now, you won't say sleeping in. Sometimes they sleep because they have to wait for an input either from the system or from the user. So we have 96 processes sleeping. Then we see that we have stopped only 0. And then the zombie section talks about a process that has been killed, a process that has been stopped but hasn't been cleared from the process table. Then we have the CPU usage, then we have the memory usage, and then the memory swap. Before we come to the table giving us the view about what each process is actually doing, the CPU usage, the memory usage, the user who is running it, and then the PID or the process ID. So these are the various sections that the top command gives us. So output divided into sections. So we have the system summary section, the CPU usage section, then we have the memory usage section, then we have the process list, that's the main table. So we have the system summary, the tasks that are running, the CPU usage, then the memory usage, and then the process table or the main table. So in a nutshell, the top command gives us a live continuous preview about the system activity and processes, and then it updates itself every few seconds. So yeah, well, the htop command. Htop command, is an improved version of the top command. It also works just like the top command. And sometimes it is not installed by default on the system, so you have to install it by yourself. So what it does is it has colors. It is able to support mouse. Maybe you want to end a particular process. The htop command makes it simple for you to be able to end processes. Mamin call terminate. So now let me end this program. So let me clear this output from the top command and then clear my screen and then type htop. Htop now it is giving us almost the same output just like the top command, but this one it has added colors, and then we are also able to use the cursor. So here I am using the up and then the down arrow keys. So the htop command gives us interactive output. Let us go down here. Then it gives us commands that we can actually use to stop or to search for a process. So when we come down here, we can see that we have F1. So me bought F1, it will lead me to the help page to show me how I can interact with the output from the htop command. So if I want to go back, I can press any key to go back. Then we have the F2, then we have F3. If we want to search to the output from the htop command, then if maybe we want to filter, so remember with the PSOX we were using the pipe and then the grep to filter. But here we can filter. That if we want to show parent processes, we can press the F5 key. Also, it has shown us the parent processes. So a process that also triggered another process to be run. PID and PPID, the parent process ID. Then I can also press the F5 again to exit from that tree section. So we have all these commands which help us to be able to navigate the output from the htop command. So if I want to exit from this htop output, then I can press F10. To be F10, I will be exited from this particular page to the terminal. Now, let me clear my screen again. But htop command is just like the top command, but here it has been improved to support mouse. It has colors, and then it is also interactive and makes killing or stopping of processes so easy.